Okay guys, now we are going to discuss about the examples. If you still remember, in nodal analysis, we already discussed about three different concepts, which is the first one, concept 1, circuit with current sources, concept 2, circuit with current and voltage source, and the last concept is about super node. So for the tutorial session, let me give you one examples. Let's say we are going to solve this circuit whereby we need to find or we need to determine the voltage at the nodes for the following figure. I really hope that you still remember our procedures. Yeah? Our procedures is about this one. Number 1, we need to observe. Number 2, we need to redraw. And finally, we need to put specific label. If this is the original circuit, in the green color is the representation of my new circuit after I redraw with the original circuit from here. Okay, if you can have a look, it is still the same circuit. It's just a matter of I put or I draw this configuration in bending with bending style to make easier to make it easy for us to understand the concept. Okay, let's say when we observe, we notice that we have this is a dependent current source and this is independent current source. As I always mention, we need to clearly understand where is Ix. So this is 2Ix and then your Ix is here. Now, I put node 1, node 2 and node 3. Let's start with node 1. So node 1 is here. So we have three different current, 1, 2 and 3. So for the first one, V1 minus V2 divided by 2, which is here V1 minus V2 divided by 2, plus V1 minus V3 divided by 4, V1 minus V3 divided by 4, and minus 3 equal to 0. So the rest is just a matter of simplification. I believe that you can follow through one by one because it is just a very straightforward matter. For example, I rearrange these terms from minus 3 into equal to 3, and then I rearrange and I multiply with 4 to simplify the equation until finally we get 3v1 minus 2v2 minus v3 equal to 12, and then this is equation 1. So for node 2 here, we apply the same concept. So we have three different current, 1, 2 and 3. So we have V2 minus V1 divided by 2, V2 minus V1 divided by 2, plus V2 minus V3 divided by 8, this one, V2 minus V3 divided by 8, plus V2 minus 0 divided by 4. So this is here is actually V2 minus 0 divided by 4. I applied the same procedure, so we simplify, okay, and then finally we can multiply it with 8, to simplify the terms, and finally we can get minus 4v1 plus 7v2 minus v3 equal to 0. Now we move to the final nodes, which is node 3. Where is our node 3? Here, and we must remember we have this diamond shape, which is your dependent current source. So for V3 minus V2 divided by 8, this one, V3 minus V2 divided by 8, plus V3 minus V1 divided by 4, V3 minus V1 divided by 4, plus, why plus? Because our arrow here or our current direction here parallel or in the same current direction with our dependent current source here, which is plus 2Ix. So we just rearrange from plus 2 minus ix into minus 2ix, and then I just simplify, multiply with it to minimize the term, and finally I obtain over here minus 2v1 minus v2 plus 3v3 equal to minus ix. But remember, our equation 1 is very straightforward. We just have v1, v2 and v3. Our equation 2 as well, v1, v2 and v3. But we are having problem in our equation 3 because we have v1, v2, v3, but here we have ix. Then this is why we need to define what is actually ix. So where is our ix? Our ix is here. Okay, so the current flow or the current direction is over here. So our ix something like this. So we have this node 1, this node 2. So obviously from here we know that I equal to v over r. So what is the v? v1 here minus v2 divided by r, which is equal to 2. Then we have this from 3 just now we have this ix. Because we want to eliminate our ix, then we need to substitute our ix with this definition. Yeah, if you look, this is the original from 3, and then I put this ix into this term, then I simplified all together until finally I managed to get 2v1 minus 3v2 plus v3 equal to 0. This is as equation 5. So apparently by having equation 1, equation 2 and equation 5, we can rewrite into this matrix form, and I'm sure you have this calculator. So you just compute this value using this matrix through your scientific calculator, and finally you can get v1 equal to 4.8, v2 equal to 2.4 and v3 equal to minus 2.4. We are done with our nodal analysis. So I will provide you with these 3 different examples through our tutorial session. It is very easy because the answers is there. You just need to prove how you obtain, for example, in tutorial 1, v1 equal to this value and v2 equal to this value for the circuit, while in tutorial 2, for nodal analysis, you need to prove I node and ix, and finally for the, this is actually, if you remember, what concept is this? This is actually about supernode. So tutorial 3, just specifically for you to understand better for supernode concept. I really hope that you fully utilize our lecture session as well as tutorial session. Enjoy your time during our PJJ, and if you have any problem, remember you can consult me. I'm more than happy to assist you. Work hard, stay safe, and I wish you all the best. Take care. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.